Greetings and welcome. We're looking at a NECAP question, 2009, numero dos. Back in the day, our school, limited number of students, we got 28% of our students got this question correct, and 32% of the state of Vermont got this question correct. So let's dive in here. This is technically a geometry concept, but it's going to relate to what we're doing today. Hoy. Está aquí, right? So this list shows the coordinates of triangle RST. That looks like a delta a little bit too, I suppose, but it's a triangle. And its image, the triangle R prime, S prime, T prime. So this is like the result after we did something to the original triangle. This is where it ended up. So to plot these points, remember that ordered pairs are listed as kind of x comma y. So -4, 6 would be over 4 up 6. I'm just estimating is probably about there. There's R. S would be -4, 9. So that would be like 3 points higher, something like that, right? And T is -9, 6. So 5 away, something like that. So here's our triangle. Right? There's our original, the OG. Triangle we've got going on there. Now, then it says R prime is over 2 up 6. Okay. So this was R. Here's R prime. All right. But we're not yet able to gather all of our information until we kind of look at the whole image here. Then S prime is at over 2 up 9. Okay. I think I've got some evidence. Oh, wait. Boy, this is interesting. Let's keep going, I guess. And T is going to be at 7, 6. So over 7 up 6. So let's see. 7 is 5 units away from 2. So something like that. Let's see. I don't know if I drew this triangle well. I might need to label some of these points. So let's see. R was the -4, 6, so there's R. S was the -4, 9, so there's S, right? And here's T. And then this was R prime, S prime, and T prime. Right? So, oh, okay, good. All right. So now I've got these plotted. It says, which transformation maps triangle RST to triangle R prime, S prime, T prime? Is it a reflection over the line x equals -1, a reflection over the line y equals -1, a rotation about the origin clockwise by 90 degrees, or rotation about the origin 180 degrees? So let's see, let's consider these rotation ones first of all. What that would mean if I was rotating about the origin, origin's right here, and if I wanted to rotate R about the origin 90 degrees, I would end up like right here for R, right? Because that's 90 degrees, and I moved it in a clockwise rotation, and these distances would be equidistant. Okay, so in that case, R was -4 up 6. I think this would be over 6 up 4 in order to land it in the right spot. So that doesn't appear to work. I think you agree, right? D, a rotation 180 degrees clockwise about the origin. Technically, counter or clockwise wouldn't matter, but that would be like, right? And it'd land somewhere here, and it'd be equidistant in the opposite direction. This would, well, at least in the case of R, that single point, it would also have been the same as mirroring it over the line y equals x. However, in respect to the whole triangle, it wouldn't end up being a mirror because the triangle would end up kind of facing the wrong way as well. Yeah, so what would it be like? No, that would be a reflection. Yeah, I think this would end up being, yeah, like that would be kind of what the triangle would look like in a 180 degree rotation. So that's also no es posible. Right? So now we've got to figure out these reflection situations, and they've really got us in a jam here because you got to figure out what do these equations represent? What does the line x equals -1 look like? Yes, good call. It's parallel to the y-axis. So here's the line, well, my impersonation of a line, x equals -1. All right, so x equals a number represents a vertical line, y equals a number represents a horizontal line. So the y equals -1 would have been this line, and it would have mapped our image down here, right? Reflect, reflect. But we've got this one, and what a reflection means is that these two distances would be the same, these two distances would be the same, and this distance would be the same. And I believe they are, and it lines up. See, at first when I was plotting the points, I was worried because this was a different distance from the y-axis, and originally at my first glance I thought these were going to be like the y-axis and the x-axis if those were x equals 0 and y equals 0. So it looks like the correct answer is A, my friends. A. So hopefully you can count yourself among one of these percentages. But if not, today's lesson, coming up in moments, will explain at least a matrices version of this concept. So, very good. Bye-bye, friends.